In part one, we have seen the basics of prompt flow, and we have run a hello world kind of example, uh, calling a simple LLM module. And now in the part two, we'll be doing end-to-end example. This is a representation of the real world logic. And to conclude this part, we will also evaluate the effectiveness of various prompts and how you use something called prompt variants. With that said, let's start our journey. As you have seen in part one, the flow.dag.yaml is nothing but a code representation of um, a template. So it's nothing but a YAML file. So I upfront created this because it's very tough to create a video and code, but I will explain every step. Nothing to worry about. So when I open that visually, what I see here is an input. So just like how you have seen in the Hello World example, here you have user passes an input, which is a question, and then as the user interacts with our application, we keep recording the chat history. We append the chat history to the context, and then we answer the question. But like before, we don't do or we don't create the context um, blindly. We do a little bit more. Mm, so let's see what logic we use. Usually, in enterprises, it's not a common practice to directly talk to LLMs and ask it to provide you the output. The reasons are many. You don't want to actually answer, you don't want the LLM to answer out of the context. Imagine a retailer's customer asking about a retailer's product, and then the LLM answers completely about some other model of their competitors out of the context. Or imagine a doctor utilizing this for a very specific purpose based on very specific data set, or a researcher wants to see a very specific information all from their information repository of journals of their organization, and you don't want the LLM to be answering you out of the context. So you have to build that context. And this is what you need to remember throughout the journey. So as an enterprise customer, your application demands much more logic between the input and calling the LLM for the last mile completion, right? Some of those tasks are you have to look up on your own data, right? So, and make sure you build that context. This is also called groundedness. So you have to actually make sure you ground your LLM not to answer things in out of context, um, and therefore you need to provide it um, or augment it with additional information that you have, right? And this is also called RAG pattern. So, in order to do that, what you do is you will first build a vector database for your organization. And as part of the vector database build, you will actually use um, any OpenAI endpoint, Azure OpenAI endpoint in this case, such as embedding endpoint, to convert bunch of the information you have, let's say the datas from the journal or the datas from the database or anything, right, that you might be having, and you convert them into something called vectors and store them to begin with into the vector database. I'll do a separate video on how to embed the data into a vector database as a vector database video, and I will actually put that link below this once that is ready very very soon. But for this tutorial, assume that there is something called a vector database which I have already built, and all it does has is it has bunch of numbers which we call the embeddings or vectors that are stored in the database along with the text content or the data content of your organization, which we call chunks. um, and we store them in some place, and we need to retrieve them just like how you retrieve a data from a database table, right? Next, you need to prepare the context. That context will be appended to the prompt, and my own logic, I can write my own logic in order to prepare uh, the prompt, right? So I don't want any prompt or any question to be asked to LLM, but I want to ask LLM the question in the context of what I am asking the question. So you will understand while you see this in action. And last but not least, when you are looking up into a vector database, you cannot look it up directly because my information has already been vectorized. Of course, I do have the text content in my vector database, but searching on the text is very inefficient. And therefore, we will be performing something called a similarity search within our vector database. In order to do so, you need to use the same algorithm that you have used in the first place to convert all of your data into a vector in a vector database. And for example, if I used one of the embedding algorithms here, I should use the same embedding algorithm here in order to embed my input so that I can perform a search. And that search is called similarity search. So let's see how this looks like in action. For example, in this simplistic scenario, I'm asking a question: what is the role of the biologics in the treatment of COVID? Obviously, I want health related information and I want COVID related information. So I first convert that into an embedding, which is a vector. And then I look up that vector. I might get one value or four values, right? So I need to prepare a context based on all of these using my own custom code. And then, like how you have seen earlier, this is a Jinja file. I build the prompt. And then we pass that to the LLM. So let's run this so that I can show you the outputs. Let's run it in the standard mode to begin with. So in the standard mode, what we can do is we run it. So let all the modules run, and you will be seeing the output. And once they are complete, I'll show you the power of debugging in this. So meanwhile, as that is processing, what we can do is, oh, okay, it processed. So let's see. For example, let me put a face to the embedding. So we spoke about something called the embedding. So what is an embedding? Embedding is nothing but user provided an input, you ask about the role of biologics, and whatever that question is converted into a vector. A vector is nothing but um, it's just a bunch of values, a list of values, right? In this case, might be, I think, the size of, based on the algorithm you use, the size changes. I think it is 1500 something for this. So that's the size of that. So you get all these bunch of values. Now you take these values and you perform a lookup. And when you perform the lookup, you said perform a lookup on vectorized field called chunk vector and return, let's say, the top three results is what you said. So let's see how this node return values to us. So this is the vector lookup. You pass this embedding to this, which is your input, and the output is whatever, right? So what is this whatever? This whatever is, to begin with, we have vectorized, for example, this bunch of text corresponding to some biologics and its related information into the vectors and stored them, right? I'll make a separate video on that, I promise. But for now, assume that someone has already done that for you. So now when you perform the similarity search, it returned the top three results. Now you need to take all these three results and make them into a meaningful context. So how did I make it into a meaningful context? Of course, with a Python program. So there's no other way though, right? So there is a special tool or a special module in the list of tools that is called, so let's go to PromptFlow Python. You can create your own Python program here, and my code is here. The only thing you need to do is you need to actually use a decorator art tool for this, and then you can write any name. It doesn't really matter. So uh, don't worry about this logic. What this logic is doing is I am going through the results and I am taking the text from those results and I am concatenating these into a content, um, and uh, the original source, right? So the content is the text, of course, corresponding to the vector, and title is which journal, for example, it came from, right? Or which chunk metadata it came from, whatever it is. So like anything, right? So this is a simple Python function wherein it can take any value and can return any value, right? In this case, it took a list of dictionaries because remember, we are returning three records from the backend database, and the three records are three separate JSONs. That means three JSON values is a list, and JSON itself is a dict, and it returns the string, which is the context. Don't worry about the logic for now. You can write your own logic, and that's not important. And then you will build the prompt, and when you are building to the prompt, you will actually pass the whole entire information in the context, right? This context is what we build in our custom program. um, we'll pass that, um, in addition to the original question to the LLM, and we also tell them sufficient information, right? So don't bluff or whatever. Then it provides us the output, right? So in this simple example, let's run it in the interactive mode now. So in the interactive mode, run it in interactive mode. What is the role of biologics in the treatment of COVID-19? So, and it returns the value, right? So, some of the good things to notice is, or to point out is, we actually have seen how we can interact um, with these tools and how we can debug. It's very important. I'm using one record, and I'm using one record for a reason. I'm using that because uh, to test with a million records, first I need to make one or two records successful, right? So each and every step, I'm seeing the output, I'm building my logic, and I'm very productive, much faster interacting with the LLM and see. So with that said, I think it's a good place to stop this recording here. Uh, and let's see in the next recording what the variants are, how we evaluate different variants, and how we evaluate the prompts.